same problems, same solutions, we're all good. Problems are different, solutions are different. And finally, I really want to take a second to talk about why businesses go to the cloud. And so businesses choose the cloud for a couple of reasons, and these reasons might not be what you thought they were. Scale, like if you need 50,000 servers tomorrow, right, but you don't need them on Sunday, like how do you do that, right? Who can do that in a data center? But we can do that for you. If you need a terabyte, or a petabyte of storage for a month, and you don't need it anymore, that kind of scale is possible in the cloud, and you just pay for it while you use it. Speed to market. We're not sure if we want to go with Postgres. Could somebody just stand one up and let's run some tests on it, and if we don't like it, we'll throw it away, right? That kind of speed to market, the ability to innovate, these are the things that drive going to the cloud. Now, in the data centers, what we often did was you had that team that pumps out the official approved virtual machine or the official approved server. They have one way of making these things. And to give credit where credit is due, that one way is the secure way, right? Security guys have hardened the operating system. They've got the logging and the agents that they need and the endpoint security. And there's one VM. So you want to stand up your project, you're going to need 6 new VMs, you requisition them, you wait for them to get deployed. And I understand, the security team, they've got it. It's been secured. It's done their way. But in the cloud, we need lots of ways. We need lots of ways to do lots of different things and make them all secure while we do them. We don't want one way to cloud. We don't want to have the security team come in and be like, sure, okay, you can totally use the cloud. We're going to make exactly one way that you can do that. Because if you do that, you're really kind of undermining the whole reason the business went with the cloud in the first place. And a couple of things tend to happen. Either you get on a few years and the business kind of says, man, this cloud sucks. And it's not because the cloud actually sucks. It's because the security guys wedged it down into this weird shape that isn't actually very efficient. Or they say, security team sucks. And you don't want to be on that side, right? You don't want that situation either. So you want the flexibility, the innovation, but you want to keep the security. And so you have to keep in mind why people are using the cloud in the first place. So that's a really important part when we think security of the cloud. There's security in the cloud. What do you mean of the cloud versus in the cloud? I'm glad you asked. If we talk about security in the cloud, you have to talk about the shared responsibility model, right? There's bits that the cloud provider does, bits that we do, that you don't. And there's bits that you do and we don't. They're your responsibility and not ours. And then there's some bits in the middle that are the customer responsibility. You're going to do it. You're going to do that with tools that we give you. So like the network routing, network rules, and security groups, you're going to decide who can talk to who. That's a customer responsibility. But you use the bits that we give you, VPC and subnets and routing tables and internet gateways and security groups. You use those things to make that happen. So it's really important to remember, the security of the cloud bit, that's our job, right? We do that and you don't. That's the physical data centers, CCTV, electric power, air conditioning, all that stuff. That's the stuff that we do. And then these other bits, especially the data, the data is yours. That's what you do. If you're going to pen test, it's worth knowing that, we have some guidance on how to do that. And we've been trying over the years to be more and more relaxed and more flexible about letting people do penetration testing on the platform. And so that's a good thing. If you're going to penetration test a customer and the customer's using AWS, we're trying to be as flexible as we can. And so the whole lot of stuff that you can test as a target pretty much without talking to us about it. Now, I have to caveat, here's the URL, right? Amazon.com/security/penetration testing. Go look at the actual rules, but I'm giving you a summary. And basically, if it's these kinds of things, go ahead and test it. Right? You don't even have to ask us permission. A few years ago, we had a form on this URL, and you had to come tell us you were going to pen test, and you had to name the targets that were in scope. And we're trying to get away from that, make it easier, make it more flexible. And so now you can just kind of do these without asking. There's a bunch of stuff we ask you not to do. And it gets back to the security of the cloud versus security in the cloud. And so there are a lot of things we ask you not to do because they could be impacting customers that are not your target. Right? A volumetric DDoS attack is probably going to affect some other customers, not just the one that you're aiming at. We ask you not to do stuff like that. The services themselves, like, don't try to pen test S3 and see if you can find bugs in it or break it or overwhelm it or make it do bad things. That's not in scope. But your customer's application running on EC2, absolutely in scope, and you can do it. So that's one little bit, like, make sure that you understand the terms and conditions and what we ask of penetration testers, because that will, it makes it easier and it helps both sides understand what's going on. And check the rules, check that URL, because, like I said, we're trying to make it easier, not harder, but check the rules every so often. So let's think about traditional security. What happens if you take, like, your typical security concerns, but you put them in the cloud? What does that look like? And one of my favorite examples of things that hopefully will kind of blow your mind a little bit is, what if your network has no layer 2? What if there's no layer 2 in the network? And that changes a bunch of stuff that you might be thinking about doing in a penetration test. So in our VPC, we've got a lot of security mechanisms in place. Importantly, the security groups are implemented at the hypervisor. So what that means is, if your instance tries to emit an Ethernet frame or a TCP packet that has numbers that don't belong to it, and the frame doesn't go anywhere, that packet doesn't go anywhere. Fire up your instance and put that interface in promiscuous mode all you want. The only frames that will ever arrive at your virtual network interface are the ones that are meant for you. So there's a lot of stuff that happens at layer 2 that, are the subject of various kinds of attacks. But if layer 2 is locked down like this, those attacks become much harder, if not impossible. I mentioned layer 2. I'm talking about these layers, and maybe not everybody knows the 7-layer OSI reference model. I'm sure most of you have encountered it at some point, right? The physical layer, like the Ethernet or the wire, copper or fiber optic. Data link layer, Ethernet or Wi-Fi or FDDI. Any FDDI token ring? Anybody? Oh yeah, the gray hairs have seen that stuff. If you're trying to remember the seven layers of the OSI reference model, I can give you the mnemonic that I use, the sentence that I say puts the letters in the right order. Paco does not trust stupid people's answers. That's the way that I remember it. That may help you now. The 7th layer, the application layer, there's more layers, right? Layer 7, layer 8, layer 9. Layer 7 is financial layer. Layer 8 is legal layer. Layer 9 is the political layer. Right? So sometimes the solution... 10, 11? 10, 11, I don't know. What you got?
Either sex or religion you can...
Oh, yeah, there you go. Sex and religion. Those would be layers 10 and 11. But that's also, again, the words of wisdom from a guy with gray hair. Sometimes you need a layer 8 or a layer 9 solution, right? Sometimes you're not going to do anything at layer 5 with cookies and session management when layer 9 is saying it has to be blue, whatever it is. Right? So when you think about like ARP spoofing or TCP man in the middle or DNS spoofing or any of these things that involve, tricking somebody by spoofing things at layer 2 or layer 3, and that stuff can't happen. That changes kind of what's easy and what's hard. And that's important because as you start talking about the risk of something you found, okay, we got access to an instance. We broke into your machine. What could you do? Think about 2 machines in your data center, 2 servers. They're wired up to the same switch. One server is .5 on the subnet, and the other is .6 on the same subnet. How much access do these things have to each other? Well, a lot, right? They share layer 2, like they share physical wire. They share layer 1 practically. And so you could send all kinds of packets either way from one to the other. And unless you're doing like OS-based firewall or you've got some pretty complex layer 3 switching in your switch, you can pretty much talk to each other. In the VPC, 2 instances in the same subnet, .5 and .6 on the same subnet. How much can they talk to each other? Not at all by default. Like, it is a default deny network. And unless you create a security group that enables some conversation between these 2 things, they won't talk to each other. They can't talk to each other. So again, you think about lateral motion. You think about somebody gets a beachhead in your environment. They get logged into an instance. Can they go to another instance? There's a lot of tools. This default deny networking might help you out a lot and make that really hard on them. So if you get into an app server, for instance, the app server has access to the database server. So that's like still a legitimate like worry. but one app server probably does not have access to the app server next to it, to another instance laterally, because why would you enable that? What about when infrastructure is ephemeral? Right, so what about when stuff just doesn't last very long? What about when infrastructure comes up and goes away? I was working with a German manufacturing customer in Munich, and they had an information security policy, and I'm helping the dev team talk to the security guys and make sure we're doing all the right things from an information security perspective. And they said, we need you to maintain a list of everyone who's authorized to log in production. That's a pretty reasonable request, like from an IT security policy, right? Anybody who's allowed to log in production, you got to keep track of that, right? You need to know who it is. And so I went and I found a blank sheet of paper. I said, okay, here's a blank sheet of paper, and we commit to keeping this sheet of paper blank for the life of the application. That's who's allowed to log in production. And they said, well, that's a really good answer, but how are you going to patch? How are you going to keep these things up to date if nobody can log in on them and patch them? And so I said, we don't patch. Instead, let's say there's some new, like we need to update Java, we need to update Tomcat, we have to update some library that we use. And so we need to deploy a version of that is secure with a new version. So you do that kind of blue-green deployment thing, right? You've got the thing deployed and running in production that's current, but needs a patch. And then you go deploy the new version into test. And you deploy it with the updated modules or whatever it was you needed to upgrade, and you run all your tests on it. Make sure that's not going to break anything. Make sure it's not going to blow anything up. And if that's good, you deploy it to production. You take your load balancer and now that's the production one. You just tear down the old one. It's gone. The server deleted. So we've lost the exposure. We don't have the exposure to that vulnerable code any longer. Now again, if you're thinking about persistence as an attacker, and these things might get thrown away this afternoon, tomorrow morning, like, you can't persist on a long-lived instance. That ephemeral storage, this instance space, is going to get deleted in the next 24 hours or next week or something. So it's not that you can't persist. It's not that those things don't work. But you might, if you need to persist more than a few minutes, you might need to move it to some place that's going to last a while. S3 or DynamoDB or a SQL database or something else. And if we make an attacker do that, that's another chance we have to catch them. It's another chance we have to see them on another channel doing some stuff we might detect. So that helps us, makes us more secure. Lambda, I'm not sure how many of you are familiar with AWS Lambda. It's, Python as a service, so to speak. We stand up an ephemeral compute environment. It's kind of like a Linux VM, kind of like a Python runtime. You upload your Python code, we run it in enough infrastructure to make it work. You pay by the 100 milliseconds for it to execute, and that's kind of it. And what that means is these containers, these execution environments that Python code runs in, they don't last very long. We reserve the right to reclaim that container at any moment, as long as we have enough out there to run when you want to run. And so this is a really effective way to, have some code run and then tear down the environment that was around that code. If someone gets your app to do something bad, like maybe write a local file, you can't count on that local file being there for very long. So if you're a bad guy, you have to do things like reinfect regularly, right? Because we're going to be reclaiming these compute environments every so often. Or you have to, persist in something that's other than the local storage for that compute function, because we're going to reclaim that every so often. And that makes you more detectable. That makes attackers, like, you have to keep continually reinfecting, or you have to continually persist somewhere else. That makes attackers more visible, and that's to our benefit. So the whole reason I mention all this is because different mental models make different vulnerabilities different risks. Right? So if you've got a long-lived server somewhere that is going to persist for a very long time, and an attacker can write in the slack space in the disk that's unallocated to the file system, they might be able to persist for a really long time. That physical disk is going to last a long time, and the server's going to be there a long time. But in these ephemeral environments, that's not an option for your attacker, so they have to do something else. Which also means you need to be watching for the something else. So this is not your father's pen test. And it occurred to me how old I was that some of you actually are young enough that your fathers could have done penetration testing. My dad was obviously never a pen tester. In the old days, you might Nmap or probe or something, see what's listening. You might be given a target network, a target subnet, a target environment, and say, find out what's listening. You would never do that in the cloud, because you can just find out. Right? You can just go query, hey, EC2, what security groups exist? Hey, EC2, for that security group, what ingress rules exist? And what it tells you is true, and what it doesn't tell you is not true. Right? So it's reliable in that way. So you would never do like port scanning in the cloud. It doesn't make any sense. Often you will test in a shared environment of some kind. Certainly in the old days, the customer will give you a user acceptance test environment, a performance testing environment, or production environment. We've certainly had that happen. The old saying is that everyone tests in production. Some are lucky enough to have a test environment too. And in the old days, that's what you would do. You'd have to have a shared testing environment. And we had this back in my prior life at Cigital. We did have someone who was working in a customer-provided test environment. And as an environment we shared with other test teams who were doing other kinds of testing. And he's like, ooh, I think they're vulnerable to SQL injection. Watch, drop table users. 6 testing teams all down tools because that test environment is just completely useless now, right? And we had to wait for like 48 hours for to roll some stuff off backup tape, rebuild the test environment, right? But in the cloud, it is trivial to spin up a dedicated testing environment. So when the intern drops table users, it's like, CloudFormation delete stack, CloudFormation launch stack. It's like, it might still be hours to get the test environment back, but we've only shot ourselves in the foot. We haven't shot the feet of a bunch of other teams. In the old days, you would think about apps on servers. And so you think about like a Java app that runs in a Tomcat or some kind of Java environment. The data is in RAM, is being passed from function call to function call in the confines of a server's memory space. So your data model, your data flow model, how the data moves around the system is one sort of thing. It's like this one app, and input comes in, moves around the RAM of the system, and an output comes out. In a serverless or a microservices design, even if you are still on premises, still in a data center, but you start to use highly containerized microservice design, you also run into this situation where you have ephemeral containers, ephemeral compute, and your mental model for the data flow is really different. Rather than being 2 or 3 execution contexts in the same RAM of one server, like you have this compute context over here that thinks about some stuff, and it stores its data to some external location, right? Like S3 or a database server, something like that. And then you have a new compute something comes up and pulls the data out. And so the data flow diagram actually can be much more complicated, and it's not inside the compute address space of one instance, but is in fact across many functions, across many instances, many containers. Finally, in the old days, you often didn't really need access to the infrastructure. Like on the list of things you need to test a website, you don't usually say, I need the enable password for all the Cisco routers, right? You don't have to get the firewall rules out. A lot of times you do that Nmap thing, right? I just need to know what affects my targets. If you're doing a cloud pen test, you probably want some access to the infrastructure, some read-only access to go find out. What's the security groups? What are the network access control lists? What are the IAM rules and policies and the roles? You probably want a bit of that infrastructure access, which your customer can't grant you. And I'll talk about ways to automate this too. So far, so good? People are still awake. I know you all are warm, but I'm telling you, ain't nothing warm like a unicorn onesie. The most embarrassing thing about this, the next most embarrassing thing about this, not that I bought it on clearance and bought the cheapest one, I did not actually buy it on Amazon.com. That's my private shame. I actually found a website, I'm not even kidding you, unicornonesies.com. And guess they were actually the first search hit. Holy cow, there's a site for everything. So let's talk about the cloud native stuff, right? So the cloud native stuff is where it gets really interesting. This is where I get really excited. If you're going to study anything about the cloud, if you're going to do any of the sort of networking and security in the cloud, you've got to learn AWS IAM. And I don't know if any of you guys saw Jamie's talk on the basics of AWS security. That was actually really good. He hit all the right notes, do what he said. That was great stuff. You need to know about IAM roles. You need to know how IAM policies work. And as a pen tester, you want to go looking around for high privilege policies. Do these things exist? If they exist, are they assigned to users? Are they assigned to roles? Jamie talked about how you don't use the root account. You really kind of want to lock it down and set it aside. So if you find people who say, well, we don't use root, we just give, the 6 developers administrator access. Okay, we really haven't done that much. It's not that much better. Right? So you want to use IAM roles. You don't want to see IAM groups, because groups, if you're a member of a group, that means at all times you have all the privileges associated with that group. And instead you want to use roles, right? So you can put that hat on, you can put that role on, do the thing that requires privilege, and take the hat off so you don't have privilege. You also want to look out for policies that have stars in them, right? Resource star, principal star, action star. You don't want to authorize big, broad slots of privileges. You want to authorize just the minimum level of privilege. And look out for this, right? Many of you are going to go Stack Overflow, you're going to go to YouTube, you're going to go to GitHub, you're going to go pull stuff down. And that example policy is going to be, somebody couldn't figure out what the right privileges were, and you know what? If you give yourself administrator access, I promise this works. Yeah, it does. So, always think about that as that second step. After you innovate, you figure out what you're doing, have that second step to go back and let's tighten down the IAM policy so you don't grant too much privilege. If you're pen testing, go look at those policies and look at what they offer and make sure that they don't have too much in them. And then finally, there's a bunch of stuff with AWS IAM users. Now, if any of you have AWS personal accounts, how many of you guys actually have a personal AWS account? Look at the hands. That's awesome. You probably have AWS IAM users, right? You've got that one user that you log in with all the time. Hopefully you're not logging in with root. If you're logging in with root on Monday, having heard 2 of us tell you not to, and having had the whole weekend to think it through, you're in trouble. I don't know how I'm going to make you be in trouble, but you're in trouble. Don't do that. So in your personal account, you probably have AWS IAM users, right? Lots of people do. But if you get to an enterprise, to a company, a big business that's using AWS, they probably don't have AWS IAM users. They're probably doing federated access. They've got their corporate directory. Those credentials are what are granting access to their cloud. If they're not doing that, I say something. Hey, you shouldn't use IAM users. Federate. And likewise, if you see IAM users, it might be because they have legacy equipment. Maybe they've got a server on premises that's backing up to S3 or needs access to DynamoDB or something like that. That's okay. That's a normal use case. But then you want to monitor and make sure those credentials get rotated periodically, that people know what they're doing and why they're there, make sure that they're guarded carefully. That's the second step of that. When you need those credentials, make sure they're protected. The cloud gives you a bunch of ways to figure out what's going on. The cloud gives you some really amazing visibility, which is another reason I say it's not just somebody else's computer, right? Monitoring the cloud is really extraordinary, and there's a lot you can figure out. What are my AWS services and APIs doing? Who's calling what? I can go look at CloudTrail, which is, all kinds of APIs, who called it, when they called it, what did they do, what was the result. You can look at CloudWatch, which can tell you a lot. If you're using Lambda functions, their logs, that print, I got this far, print, I got this far, print, I got a little farther. That's all going to go to CloudWatch logs. Are my resources changing? So AWS config is really, really good as a flight recorder, flight data recorder for your cloud. Every change to every resource that config supports will get recorded in some change database, and you can rewind over time. And I love this possibility. Imagine someone coming to you and saying, prove to me that nobody can SSH into that EC2 instance. So, let's take a look. Here it is. Here's a security group that's in. It allows SSH in from the data center, and that's all it allows. Sure, but Maybe you knew I was going to ask that. Maybe you changed that 5 minutes ago, because you can just do that with an API. You can say, oh crap, here comes Paco, lock everything down. Right? You have a Lambda function that just locks everything down. And then as soon as Paco leaves, you're like, unlock, and everything goes back to crap. But with AWS config, like those changes are recorded. And so I could actually go into AWS config and I could click on that security group and I could say, run it back for a year. Show me all the changes to that security group for the entire last year. And I can say, yeah, at no point in the last year did that security group have a rule other than the one you see now. That's pretty powerful, actually. So I love stuff like that. You can get some real powerful views on your cloud. Are there any security events I should know about? The cloud gives you some really neat events, like Guard Duty is my absolute favorite service on the platform. Can't say enough good things about Guard Duty. Super inexpensive as services go, super valuable for the results it gives you. If Guard Duty is warning about something, you should probably take a look. Some things it can detect that you can't see any other way. Imagine someone's coming to your AWS environment. They're like logging in to the console, or they are invoking AWS APIs, but they're doing it from a known Tor exit node. So it's a legitimate connection, legitimate use of your resources, but coming from a Tor exit node. Now, there are not many legit business use cases for that. Like, very few organizations would say, oh yeah, our guys are logging in from Tor all the time. All the sysops guys always use Tor to get to the infrastructure. That doesn't happen very much. So we actually alert on that. Because if it was authorized, but it was coming from Tor, that may be an indication of like, yeah, somebody that's not supposed to have access has access. Or, if your VPC starts making a bunch of DNS resolutions, they're resolving a bunch of DNS names, and they're all related to Bitcoin mining sites. Again, not a ton of business use cases for that, but it might be an indicator of compromise. And if you saw my talk last year and I talked about incident response, I often talk about AWS billing as a service being a really interesting indicator of mischief, right? You can get alerts on your AWS account, and especially if you have a personal account and you don't plan spending more than 10 quid or 20 quid or whatever a month on it, like put a billing alert in there so that you find out if you do. I've seen these instances where, the customer's tooling along at, thousands of dollars per month, and suddenly, you're spending $65,000 a day. Is that what you meant to do? In a real environment, what you want to do is, you may have a team that spun up some new stuff. Remember that innovation? And so maybe it's going to be a false positive, but you want that visibility. And customers who are not looking at the billing as a security indicator should. Trusted Advisor. Like, Trusted Advisor is another one of these. I got to check for a bunch of it's like the check engine light on your cloud. Like, you ever get in a car and somebody's driving, your friend's driving you somewhere, you see that check engine light on, you're like, come on. Like, your car is in trouble. Like, the idiot light is on the dash. Right? If check engine light comes on in your cloud, you should probably go take a look. Right? And Trusted Advisor is that. If it's whining about something, if it's warning you about something, you should probably go take a look. It'll check for public, things that are exposed that shouldn't be exposed. It will check for common misconfigurations. And interestingly enough, it's really good at telling you, you're spending more money than you have to. If you did things differently, you could save some money. Trusted Advisor will literally tell you when you're spending more than you might need to. So, useful thing to have a look at. And finally, what's going on in the EC2 resources? If you got varlog, syslog on your Linux box, or your Apache logs, or your MySQL Server logs, or anything that's actually on the instance, you can pull that out into CloudWatch logs and start searching it and looking at it and manipulating it and alerting on it. So these are all the different ways you might monitor the cloud, and these are things that don't necessarily have any analog in a real data center, right? In just an ordinary data center, you don't have this kind of stuff. And if your customer's not doing these sorts of things, that itself is probably a pen test finding. Like, you can't see stuff in your cloud that you could see if you looked. So we heard about infrastructure as code earlier today, and that's a really important point. That when your infrastructure is code, right, we deploy infrastructure using code. The network didn't exist until a line of code made it come into existence. That routing table didn't exist until we wrote a line of code that set the routes in it. Those instances weren't ours and didn't come online until we wrote that code that made them come into existence. So if infrastructure is code, infrastructure security is code, right? Doing your infrastructure secure means changing the code that creates the infrastructure. And that's really important. You need to know how to read the code, detect things going wrong, and then write robots to respond to this stuff. So, like, one of my favorite config rules of one of our customers here in the UK, a big mobile phone company in the UK, they wrote this one. Where basically, they have some public-facing security groups that are open to the world. And they put tags on them that indicate that, yeah, this is one of the approved internet-facing security groups. But if somebody comes along and creates a security group open to the world and it doesn't have the right tags on it, they don't delete it, right? Because deleting the security group would probably wreck whatever it was they were trying to build. And they don't, like, shut down the whole project that they launched, because that's kind of disruptive. They just rewrite the one ingress rule. Like, well, if you were going to allow ingress from 000 from the whole internet, well, we'll just change that to 10.0.0. Right? So now you can get ingress from anywhere in our VPC, anywhere in the corporate network, but it won't be ingress from the internet. A really handy way to just kind of clamp things down without being too disruptive. So security in the cloud is a lot like just good engineering, right? So remember with the CIA, right? The confidentiality, integrity, availability, your classic, sort of three things in security. And availability is one of them. We have had customers call up. We had customers call up and say, oh my God, we're under attack. All the load balancers are streaming and all the auto-scaling groups are maxed out. And, our team spins up and take a look and all this stuff looks legit. I don't see anything that really looks like an attack. And it turns out that marketing ran a Super Bowl ad. Forgot to tell the IT team, right? So Super Bowl ads get attention. And, it looks like a DDoS attack. It's not. It's, marketing working as designed, and IT just didn't get the memo. So engineering for that kind of success ends up taking you in much the same direction as engineering for a DDoS attack, too. Like having resiliency in terms of availability, fault tolerance, having resiliency in terms of, latency and high availability configurations and load balancers instead of instances just straight on the internet. And that kind of design will make you much better to deal with a DDoS attack, and it will make you better if your product or service or whatever is wildly successful. So those two things go in the same direction. And I love tabletop attack simulations. Doing these tabletop exercises where you think, what if? Sit down with your customer. If you're doing a pen test, try to get some people in the room that are like, the DevOps guys and the developers and the product owner, and if you can, somebody from public relations, somebody from legal, maybe even somebody from human resources, and start posing these scenarios. What if? We had a situation at a UK government agency where security researcher, white hat, someone with good intentions, contacted them and said, we found a bucket, a public open bucket with a crap ton of data that looks like all your citizen data. And of course, immediately everyone, runs around like crazy, oh my God, what are we going to do? And, they've got 35 AWS accounts, goodness knows how many buckets in each of those accounts, and you've got this bucket name, you're just running around trying to figure out what it is, and is that our data? They're briefing the minister in case he has to say something to Parliament about, oh crap. When we got to the bottom of it, it turns out that they had hired a third-party contractor to test some application, and this third-party contractor had generated a bunch of test data that was really good test data, very, very realistic. And yeah, they had put it in a public bucket, right? So, they shouldn't have it in a public bucket, but thank goodness it wasn't actual citizen data. It was a lovely fire drill for the department, and it really made everybody sort of think, we need to practice that. And that's what these tabletop attack simulations are like. You sit a bunch of people around the table and you just say, okay, what if someone came to me and said, we have a public bucket with a bunch of our data exposed in it. What would you want to do? And your gut says, delete the bucket or delete the data or, close it all down. And that's good, but after you sit around that table and start talking to people, you realize someone's going to ask, did anybody access that data? I don't know. We weren't instrumented to look for that. How many people access that data? What data was it? How did that data get in that bucket in the first place? Who was it that set that bucket public? Right? And you're going to have these questions come out in that roundtable discussion as you sort of war game this exercise. You're going to think, ooh, we're not ready to answer those questions unless we build some infrastructure and build some extra logging and build some detections. And so these tabletop attack simulations are really, really valuable. So let's talk about better living through automation, right? We talked about pajamas and how robots let us wear pajamas. And that's really kind of, what I want to get at. I had a conversation with Steve Schmidt, who's our CISO. So he's the CISO for all of AWS. And I said to him, look, Steve, alert fatigue has got to be like a big deal. You guys know what alert fatigue, right, is? Yeah, it's like that same error message, yes, it's fine, yes, okay. And move all your money to Malaysia? Sure, yes, whatever. And, you just keep clicking yes, right? Because you're just tired of seeing alerts. And I thought, gosh, with our security operations, we see so many alerts, so much stuff going on. How do our people avoid alert fatigue? That must be a real thing. And they had a one-word answer. It's like automation. Anything that we see a lot of, we go write some code to deal with the majority of it. We want to be able to deal with 75% of whatever the tickets are with a function that just knows the right way to resolve them. Like that example that I gave you of the 000 becomes 10,000. We try to write stuff like that. So if a human gets alerted, it's probably something that either isn't decidable by the computers. It's going to take a person to make a judgment call. Maybe it needs approval. Maybe it needs, we got to ask some questions. Or it's probably something we've never seen before. Like this doesn't come up. So let's have a human make a decision. The other thing that's really interesting about how we do security operations is Amazon has a ticketing culture, lots and lots of tickets. I've filed about 7 tickets to be standing right here. And in security operations, we don't have a big wall with a map of the world, the packets going around, and that kind of stuff. We don't have any of that. We do have a ticket queue, like what are the high severity issues we need to be dealing with right now? And people are assigned and watch and track them and run them to closure. What's really interesting about most of our security tickets, the vast majority of our security tickets are created by robots. They're created by code that detect things and say, whoa, this is out of alignment. I don't know how to fix it. I'm going to alert the humans. And that's what you're looking at for better living through automation. If you're going to do pen testing, there's a couple of good programs out there that can help you do some good pen testing in AWS. Prowler, if you know Tony De La Fuente, he used to work at Alfresco, works for us now, AWS ProServe, he's over in Madrid. And so we love Prowler, does a really good job of running through AWS accounts, running through all the regions, figuring out what might be exposed in the public, it might be a region you don't think you use, but somehow you've got some stuff over there. All that stuff can get detected by running these shell scripts. Scout Suite, we got any NCC people in the house? We got a few, awesome. So NCC produces Scout Suite, which does a really nice job, very similar, producing a nice comprehensive HTML report of all the traffic found in your environment. And one of the things I really love about the Scout Suite report is that it kind of looks like a web page. It's an HTML report with links to the console, to the resource it's talking about. So like this instance has blah, blah, blah. You click there, and you go right to the console, looking at that instance, and then you can go kind of take a look. So really, really handy tool. Both of them are open source, so they're readily available, easy to run. So last couple parting shots here. First off, learning the cloud pays off. These are the top 15 certifications, top 15 best paid certifications. The data is normalized to US dollars, but it's not just US countries that are participating in the survey. And it's like 20,000 participants or something. It's a really large number of participants in this survey. Basically asking you what certs do you have and how much money do you make, and a few other demographic details. And so you look like 5 of the top 15 are cloud certifications. I even put some other clouds up there. And, a bunch of the top, like 3 or 4 or 5 of the top 15 are security certifications. So like if you got a few of these, you got some cloud certifications and some security certifications from a career perspective, you're looking good. This stuff means money. And then, if you can't stand any of that crap, look for project management will make you a good bit of money too. You get your PMP or something. But the point being that there's a bunch of certifications. We have the AWS certified specialty certification in security. I wrote a few of the exam questions on that one. I'm very sorry. Just apologize now. CISSP, if you do that one, yeah, I wrote a few of those. Sorry. It's actually kind of a non-trivial certification. It's pretty hard, right? It's like, you want blah, 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 blah to happen. One of these 4 IAM policies will do that. Which one? It's actually kind of non-trivial. They're real questions. So those are worth doing. And we also, we are builders, right? Amazon is all about builders. We want people to build things secure, do wonderful things. Building is better than breaking in the sense that anybody can kick over a sandcastle, right? Not everybody can build a sandcastle, and not everybody can build a sandcastle that can withstand a wave or two. So, building is a really valuable skill, and people are really looking for builders. Always remember, learn what makes the cloud, because it matters. It's not just somebody else's computer. And that free tier, a bunch of you came by the table today, great. The AWS Educate, go use those promotional credits to go run things, at our expense in the cloud to learn. Want to give you a shout out, a plug for what we're doing tomorrow in the Hack Lab. We're going to run a thing called the Security Jam. Now the Security Jam, we're bringing the AWS accounts. You bring your laptop. We will provide the AWS accounts running all kinds of different services and situations, and you compete for points by solving challenges. And it's all hands-on. You're going into live AWS environments. Real instances, go log into that instance and see what went wrong, or go read these logs out of S3, use Athena to query them, and find out what went wrong. A lot of really neat stuff. It's a lot of fun. And if you don't know AWS, if you really barely know AWS at all, that's okay. Every single question, every single challenge has several hints in it, and the third hint is the walkthrough. So if you don't know what you'd like to learn,